Okay, we're back. So now we have a background in event processing. We can handle the keyboard events. We can handle the mouse events. And now we would like to address the question of how to transmit data structures across the network using RMI. Does that about cover it? Yes? All right, so for now, and we'll deal with other questions as they come. You can ask any question you like. I'm going to go to my Hello World server. So here's the Hello World server. Just to recap, I'm going to go through a little bit of a line-by-line analysis. It's not a particularly long program, but I'd like you guys to just keep in mind what's going on here. The Hello World server has a main method, and the main method calls start server. You got a question? Okay. So then what it does is it says under start server, it says print line starting server. He creates a new instance of a remote hello implementation. He binds the instance using the RMI registry, which uses the singleton pattern get registry, which starts the registry if it's not already started, returns an instance to the registry, rebinds to the registry using the name remote hello on the local host. So it's communicating with itself using the RMI substrate, RMI protocol. What layer am I in? Think about your OSI reference layers, right? The 7 dwarfs. Dopey, sleepy, sneezy, doc, bashful, happy, and the other guy. Nobody can remember the other guy.
I know in Spanish.
Wheezy. I think he was wheezy. Because he had like a cold. No, sneezy. That's it, sneezy. So there was something wrong with him. But there are also 7 layers, right? The 7 layers. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Of those 7 layers, which layer are we in when we use RMI protocol? It's higher than the physical layer, because physical layer is just bits, right? It's higher than TCP/IP because it's built on top of TCP/IP, so it's higher than the transport layer. It's lower than application layer. It's higher than session layer. So what's left? Presentation layer. Thank you. So we're in the presentation layer using RMI protocol. It's the same layer you'd be in if you used HTTP for hypertext transfer protocol. Also presentation layer. And now you want to print out waiting for invocations. And so the only thing left here is to sort of see, geez, what does this remote hello implementation do? Right? So he's waiting for an implementation invocation, which is to get the message, and locally will print out I am running, ooh, and then return a message to the client, hello, CR320. Hello, I'll just write client. Got that? So let's start the server and expect that it will print starting server. Expect that it will print binding remote instances, and expect that it will print waiting for invocations. And perhaps it will do it while we're young. Oh, and there it is. So there it is. It starts the server. It bound the remote hello implementation into the registry using the remote hello string on the local host. Now he's waiting for invocations. The server is running, I need a client. Right? What is it with you and the buzzing? Can you stop the buzzing, please? Thank you. So now here's the client. No more buzzing. Are you texting? What is going on over there? We're blaming the service provider now?
Well, I sent the message like a while ago, and for some reason it keeps sending and sending and sending, and I'm not doing anything.
I'm sure the entire class wanted to hear this. Can we file that under too much information? So, right, here's the remote hello client. Thank you for sharing. And here's the deal. I want to start with some kind of a location, and we're using a URL. So the URL is going to have localhost in it. It's going to have the name of the service we're looking for that's been bound by the registry. We're going to want to do some kind of a lookup to find the service, and then we're going to want to do an invocation. So here comes the registry. I use my locate registry invocation. I got a port. The port's going to be the standard port 1099. I'm going to get the registry based on that. I'm going to look up using my RMI URL. The RMI URL is one we've already agreed to. It's got a host name. Fully qualified domain names are not needed because we're on the local host. But if the local host were on the internet and you wanted to gain access to that internet-based RMI server, it might be something like, give it a machine name. Call it RMI. Give it a fully qualified domain name, docjava.com. And then you could go in on port 1099 from anywhere in the world and go invoking services on rmi.docjava.com. So you could supply these services on your web server and make yourself exposed to anyone who knew your RMI protocol, which may be like nobody but you. But you know, this is if it's secure, it's security through obscurity. It's not secure because you've password protected it or used secure sockets. It's just secure because nobody knows your protocol. Actually, security through obscurity works because nobody will find your machine worthwhile hacking by trying all different possible protocols. It's just too hard. But they might try, if they know, some of the stuff that they've seen before. You won't stay secure for long. So then I go to my remote hello client. I do test get message, and presumably that will call get message and print out hello client on my console. Also on the server, we can expect a response on the server's console for when the server's invoked. It may want to print something as well. So the remote hello implementation, when it's invoked, will print on the server, I am running, and that'll be printed on the server. But it'll also return the message, and the message is hello client. So the client will print out hello client, and the server will print out I am running, So let's see if that works. I want the client. RMI hello client. Run. So it returned hello client, and on the server we said I am running So the server responded by printing something locally on his console. The client responded by printing the message that was returned by the server. So we are communicating using the RMI protocol. So everybody sort of got that? Did I go too fast? You don't understand. You do understand. Everybody's good with this, right? Okay. So now, next step. Let's review what it is we need to transmit from one place to another. As far as I remember, the only thing I needed was a character, a Boolean, and an integer. There was probably more than one integer. One was a score, the other was x. But that's it. All right, why? Thank you. Huh? It matters. Yes, it matters. So let's create a class that we can pass from one place to another. An instance of a data structure that contains the stuff that we care about. And what I will do is I'll put it here and call it class
Would you mind making it a new file?
Pong. I'll put it in a new file. Pong data structure. How about just Pong data? That's good, right? I don't have to call it data structure because it's silly. Pong data. So Pong data contains. You want it in a new file. Let's do that. So we'll put it. We'll make it public. That'll cause the IntelliJ compiler to complain, and then we'll move it to pongdata.java under simple example. And we need a couple of variables. One of these is a private integer y. Another is private integer score, which I will set equal to 0. And the y coordinate I can set equal to 0. Let's give it default values, even though it's probably 0 by default anyway. I will not rely upon that. I'll make it explicit when I instance the Pong data. What else do I need? Boolean is clicked, was it? Equals false. And what else do I need? Character. R. Well, character restart. Whoops. Shoot. Restart. R-E-S-T-A-R-T. Re-S-T-A-R-T. Thank you. Equals. R. Maybe it should just be a Boolean. Is restarted.
Yeah, I was gonna say, can we just use a Boolean?
Yeah, let's just use a Boolean. Boolean is restarted. Because there's only one character that we care about. And when that occurs, we can just set is restarted to true. Okay, so now, since everything is private, how will we get and set these things? Okay?
Private methods.
They're I want methods, right? Setters and getters. So I'll just try to do some kind of refactoring here. Refactor this. What's that do? Encapsulate fields. Click, click, click. Use setters and getters. Refactor. And that's that. And that's how you do that. What do you think of that? Say, work smarter, not harder. I hate people who say that. What? So now you want to pass this across the network. How are you going to pass Pong data across the network?
Just be serializable.
Yes, serializable. So it implements serializable. What else do I need to do to it? That's it, right? It's the data that gets passed. So it doesn't have to have its methods throw remote exceptions.
So
Because once the data is passed in, you can then interrogate the data structure to get the data out. So because it's going to be passed as an object that gets marshaled across the network to the client, presumably the client will be able to go into that data structure and get information like, was something clicked? Was it restarted? Is the y coordinate different? And in fact, all you have to do is get y and then set the local y, get the score, set the local score, check the is clicked or is restarted, and then proceed with your execution.
so as far as the Pong game is concerned, do we not need to do anything
What do you mean
with
you don't need to
RMI?
do anything?
With RMI, like I wasn't finished yet. Do we need to do any RMI on the actual game itself, or is it just this data that we're passing?
You're passing the data. The RMI methods will have to somehow pass the data to the peer in the Pong game. So when my mouse moves, you will receive an instance of Pong data. When my characters are clicked, you will receive an instance of Pong data. When the score changes, you will receive an instance of Pong data. You'll have to update the state of your game as the Pong data comes in. So your paddles will move, your scores will change, your games will restart, your balls will launch. Your game is controlled by Pong data, and Pong data is passing information back and forth. So when you click, presumably, not only does the ball launch at your side, but it will launch with some latency on my side, right? Because I need to see the ball track across the different machines. I'm not passing ball information, but I am, well, I kind of am. I'm passing launch the ball information. So then presumably the balls launched at the same time, or nearly the same time, will track one another.
Don't you need to track the position of the ball too?
Well, this is a big question in
So
my
they
mind.
see
If my paddle moves, your paddle on your side will represent my paddle, and it will hopefully
So it should
move
be
with
identical.
relatively little latency. But it's possible that the latency is so great that my paddle will hit the ball, whereas the paddle that doesn't track my paddle perfectly at your side misses the ball. And what looks like a point to me might actually look like a point for you. So, in a sense, if things don't track exactly, and if there's a lot of poor quality of service on the network, this game might not work. So this is an interesting real-world test when you go across different machines with varying quality of service on a real-time game. It's an interesting problem, and I've never done it before in this class. So we're all going to learn. And if it doesn't work because of latency, I will not hold it against you. I think what we'll do is we'll all learn about it together. How's that? So don't let it bother you if you find out somebody is, making scores and those scores aren't properly reflected because you missed the ball at one end and there was a latency problem. That's life. That's what happens when you deal with, real-time games on a RMI network. RMI is not the most efficient, lowest latency way to do communication. Could have used sockets and cut the RMI overhead out. Could have done. That's what a lot of people recommend. They also recommend some of the higher performance networking protocols. But I like this RMI at least in part because it lets you do other kinds of complex tasks. So we'll give it a go, and if it doesn't work out for us, then we'll put that in our pipe and we'll smoke it or whatever. I mean, it's just, we went into this knowing RMI wasn't the highest performance networking protocol, and not caring because it's not a critical problem. It's just a game. I did do an RMI game with Java 3D. It's called Kill the Student. And I played it as a massively multimedia online gaming thing in Java 3D. It's actually part of the Java for Programmers distro. But I've never done the Pong thing, which needs a lot more real time. See, in Kill the Student, you're walking around in a maze. And it's very slow, except for the bullets, which go fast. The Pong game, everything's always in motion. So that's kind of a different thing. So how can we make an instance of Pong data and represent it? Well, I would say first thing we should do is test our little Pong data class. Let's take an instance of it in public static void main control J, make a new instance of Pong data. Pong data PD equals new Pong data. Okay, and then what we'll do is we'll print it, and we'll just print out the Pong data. And I like having a little print statement in here because it kind of underlies the need for an override on the primordial java.lang.object2string method. And let me show you what I mean by that. When you print out an instance of a class, you'll only get a hash mark with a hexadecimal reference address data type, which looks like this. That's not particularly informative. If, on the other hand, you want to override the string representation for your instance, you override the public string toString method, and then you can make its string representation represent anything you want. Hello world. End quote. Oops. So now when I run the same thing, it prints out eventually hello world. So what you might like to do is make it print something better than hello world. Like, for example, quote y equals end quote plus y, and plus quote comma quote plus quote is restarted equals quote plus is restarted plus quote space score equals end quote plus score plus, this is a nuisance, is clicked equals quote plus is clicked. And I could have used reflection to do all of this, but I kind of like this real simple approach because I have this idea that I should just keep it simple. And now when I run the program, what happens? And I want to know about this sort of thing with a print statement because before I start adding the business logic for playing the game, I want to verify that the data has been correctly transmitted across the network by having some real print statements print out some real data. After that, after I've validated the data and I've printed it nicely and I can format it and see it, then I can go and write a game around it. So I really need to start with this real small data structure with this real simple print statement, then pass it across the network. If you see what I mean. I'm designing from the top down, but I'm building and testing from the bottom up. And I test as I go, because otherwise I have no confidence in the code that I've created, if that makes sense. It's kind of like, I know what the house looks like, but I really want to make sure I know how to use a brick and lay bricks down. And if I've never soldered before, right, then what happens is things just kind of look kind of crummy and nothing works, and you soldered the whole thing all at once and you never tested anything. Where have we seen that before? So up to now, everything is clear to everyone? Nothing up my sleeves? No existing code? All good. Just to recap, we got keyboard events, we got mouse events, we got information from these things which we can now, I think, clearly pack into Pong data. We've got serialized Pong data, we're printing the Pong data, now we can take the mouse events and we can pack them into Pong data. Isn't that right? Okay, so let's go back to our little mouse example. And let's run the little mouse example. And R, reset, click. I have been clicked. It's all good. So now what I'd like to do is go into my Pong data. PD equals new Pong, Pog, Pong, Pond, Pog, Pong, data. It must be getting late. Alt Enter. And so now I need to populate my little data structure. And so let's do the following. Let's make it final. And then let's use PD dot set restarted to be quote, true. Else, I'm thinking, I don't need an else in here. So what else can happen?
Have it print, like, click R to restart. You hit something that's not an R. So, like, they actually
yeah, we could do something like that. Else, S out, Control J, enter, quote, click, press R, I don't know if I can do that, R to restart. Whoops. Darn trackpad. Restart. Okay. And now to make a single quote, I need a backslash to escape the single quote. Backslash single quote. Backslash single quote. There we go. And now, what else do I need? Something like, I've been clicked. Okay, so now I can go to Pong data. Pong data dot set clicked to be end quote true, and Pong data dot set restarted equals false, right? Because if you're starting, it's not restarted. And then if somebody restarted, I think you should say set clicked equals false. pd.setClicked is false. There we go. So it hasn't been clicked if somebody hit reset. That means you won't be starting until someone hits clicked. So now what? Something about moving, right? Here it is. So here it says get x, get y, but somebody said something like I only need to set y. So pong data dot set y to be e dot get y.
Would just be dot y, because then it's an int. What you said?
Yeah, but isn't this an int also? Yeah, it's an int. So e dot y and e dot get y are the same. Is that true? What does e dot y do? Yeah, it returns y. Okay. And where's y defined? Over here, it's an int. So e dot y and dot y, all the same. So what else? This won't actually print the value of the data. What are we calling this now? Pong data. So what I could do is whenever the mouse is moved, I could print Pong data. Is that too noisy? I could do that anyway. What do I care? Pong data. And I happen to know that Pong data has a nice string representation because I went to the bother of giving it a nice string representation by overriding the java.lang.object toString method. When I say that's a primordial object, you never subclass java.lang.object explicitly, although you could. You could. And it's redundant because all classes subclass java.lang.object. Isn't that interesting? Little Java trivia there. Yeah, impress your friends. So I mean, I won't make too fine a point out of it because by doing that, but you could. I mean, you could say extends object. Right? And then what does he say? He's complaining. He says, remove redundant extends object. Right? Why? Because java.lang.object is redundant because they always subclass that. So now let's run our little mouse example with the built-in serializable Pong data instance. How am I doing on time here? Oh, good, we have time. Before I do that, are there any questions? No? So all I did was I populated the data structure with the prior demo of the mouse event and keyboard event class. Here comes the data structures, is restarted false, y coordinates changing. Let's click. Now click is true. The y coordinate is still changing. Now let's hit R. So it did reset. Now reset is true, clicked is false. Score is 0. I'm not changing the score. So it's all good, right? Everybody's good with this? So far all I did was populate a data structure with my little event processor. You're all very quiet. Rhodey, you woke up? Looked like you were sleeping over there. Okay. So now what? Is it time for RMI now?
To implement it. The implementation. Or the interface.
Implementation, interface. How about we just make an instance of Pong data and use RMI to pass the Pong data from a server to a client? Does that sound like a plan? We're good? Everybody's good with that? Okay. So, I got an RMI hello server already, and it has an RMI hello implementation. What if I took the RMI hello implementation and let's see, what does the remote hello method do? It has a message, get message. What if I had something like
Should we probably use a new file?
yeah, let's make a new one. Let's make a new one. How about we do an interface called remote Pong data. And we call it remote Pong data. Extends remote and returns Pong data, and we call get data. And it lives in the remote Pong data class. How's that? So it's just like remote hello, only with a difference. And the difference is it doesn't call get message, it calls get data. And when you call get data on your remote server, presumably it could throw a remote exception, because when you're on the client and you're trying to communicate to the remote server, it could time out, it could do all kinds of interesting and wonderful things, be unreachable. So this is one of those things that you have to try and handle.
So that's a method that we haven't implemented yet. Great.
Right. You still need a remote Pong data implementation. Just like the remote hello implementation, only with a difference. And it'll subclass the unicast remote object I'm going to copy and paste it so I don't have to type everything. So what we'll do is we'll make a remote Pong data implementation. Remote Pong data implementation, and we'll put it in why is he giving me a hard time on this? Can I move it?
The whole thing.
Move it to simple example. There we go. Where did it go? It must be under simple example, right? Under RMI. So it's probably under net.rmi.simpleexample.remote Pong data implementation. And it has to be called remote Pong data implementation in its constructor. And it needs some Pong data. Private Pong data PD equals new Pong data, and it implements the remote Pong data interface, which means it needs to implement the methods get data and return Pong data. It does not need the message, and it should return Pong data, and that's it. Shall we make it so that it can set the Pong data? That way we can have two-way communication. Well, let's do this first. What shall we do for the Pong data? I suppose we could say something about it. How about Pong data dot set clicked equals true, just for fun. That sounds good, right? So now I need a remote Pong data server. Right. So what did we need? We needed the remote Pong data interface, a remote Pong data implementation, a remote Pong data server, and then we'll need a remote Pong data client. Right? For every server, you must have a client. Got that? So here's the RMI hello server. I'll copy and paste that. And give it a name. Let's call it remote Pong data server. Remote Pong data server. And it'll call start server, and it'll bind the remote Pong data implementation to the remote Pong data interface, and then it will proceed to give it a name, and we'll call it remote Pong data. And it'll wait for remote Pong data. And he's unhappy because he's in a RMI hello server.java file. So what I'll do is I'll move it to the remote Pong data server.java file. And now I've got a server, and I've got an implementation, and I've got an interface, and what am I missing? A client. Next obvious thing. Let's go to the RMI hello client, make a copy of that, and create a RMI, what do we call it? A remote Pong data client. How's that for a name? That's good, right? Nice and logical, sort of. It's a little wordy, okay, but I'm trying to be methodical about the whole thing, you know? So here's the RMI hello client. We'll make a copy of the RMI hello client, paste it in just like before, only we're going to modify it to make it the remote Pong data client. Remote Pong data client. And that will take a remote Pong data client constructor and look up the delegate, and the delegate will return a remote Pong data interface. Remote Pong data interface. Copy, paste, paste. What is he on about now? Paste. And now he's probably bumming because it needs to be put somewhere, but there's something else going on here he's complaining about. Oh, he's calling test get message, which is not going to work because it's not a remote client, right? It's a remote Pong data. Oh no, it is a remote. It's a remote Pong data client, which he will get from remote Pong data. Pong data. That's what we called it, right? So then the remote Pong data client will... It doesn't have a test message, does it?
No.
It shouldn't do.
It's just get data.
Oh no, I have a test get message. I guess I can call something like get data. And there's something else bugging it. He says you should make it in its own file called remote Pong data client.java, which I will do. So now let me recap. I got, we need better names for this. I got a remote Pong data client, a remote Pong data server, a remote Pong data interface, and a remote Pong data implementation. I don't know why, but I'm reminded of an episode from a Woody Allen movie called Sleeper, where he decides that he's going to play the crazy dictator, and he's decided that everyone will be required to change their underwear every hour, and to ensure that they are doing this, they have to wear the underwear on the outside of the pants to facilitate checking. And I'm like, it's like some kind of nutty thing, you know, it's just so wacky and kooky. Why would anybody call something like this? But there it is. Remote Pong data client. Okay, so let's run the remote Pong data server. How are we doing on time here? Good, good, good. I think we're going to actually... Oh, it's waiting for remote Pong data, it says. Let's try the remote Pong data client. Okay. So the remote Pong data client apparently was able to get is clicked is true. What did the remote Pong data server say? Waiting for remote Pong data. Huh. I guess it doesn't do anything when the Pong data comes through.
Did you click it?
Well, I didn't create any interface, no GUI. All I did was pass data, a data structure from the server to the client. So if you go back to the remote Pong data implementation, you could have done something when someone called get data, like you could have said something like I don't know, S out, Control J, enter, let's see, sending data, right? And so now when the server runs get data, and then prior to it passing it back across the net, it will print on its console sending data. And then on the client, what we can do in the remote Pong data client is prior to its printing out data, it could print out something, some message that says getting data. Then it'll get the data and print it. So the client will print out getting data, and the server will print out sending data, and it will send the data, and the client will get the data and then print the data. How's that? Just not to put too fine a point on it, if you try and run this client without running a server, something bad will happen. Like it'll not be able to look up the server on the registry, and it'll die horribly in flames. So if you see a message like connection refused to host, blah, 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 nested exception, connection refused, blah, 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 get used to it, because that means you forgot to run the server. So that's what it looks like when you forget to run the server. So don't forget to run the server. And brush your teeth before you go to bed. And always close your files when you're done. And let's see. Remote Pong data server. Let's run that. No, wait. That's the interface. Where's the server? Remote Pong data server. There it is. And waiting for remote Pong data. Good, good. Now we go to the remote Pong data client. Why isn't it showing? Oh, you know what I need to do is I need to resize this console. Yeah. Wait, stop that. I'm spazzing out. Here, let's just close that. Now, where's the remote Pong data client? Here we go. Run. Getting data, and it's restarted. Now let's go to the server, and it says sending data. Getting data, sending data. Getting data, sending data. Got that? It's all good?
Does it respond to like weird things though?
No, I haven't shown a graphic user interface on the on anything yet. That would be a next logical step. So Kyle asks, does it show the clicks? Well, the answer is of course no. I haven't shown a frame yet, and what I would need to do is I would have to somehow on the frame initiate the information. Now, where would I put that frame? So far I've been able to look at the you got a question there? Just stretching? I've been able to get the Pong data and print it. I haven't tried to send the Pong data. So I thought it would be good if the remote Pong data client could have a peer-to-peer relationship with the remote Pong data server. That is, it should not just be able to get data, it should also be able to send data. So the server remote Pong data server uses a remote Pong data implementation. Let's see if we can find it. Remote Pong data client looks up the delegate, calls test get message. How about if we tried one called set data instead of get data? So here's get data off of the remote Pong data, but there's a remote Pong data implementation which we could modify, right? Suppose you said to me, I don't want to just get the data, I also want to be able to set the data. Right? To do that, I would like to go into this interface and I would like to modify it so that we can have what I would call a peer-to-peer relationship between the client and the server, so that the client and the server can communicate with each other back and forth. So in order to do that, I would need to modify this implementation and make it possible to set the data. Now, does it make sense to do this? the score is shared, so that's okay. If somebody clicks, the game is started. If somebody resets, the game is reset, so that's shared. But what's not shared is the paddle position. You want the enemy paddle and your paddle to be separate variables. And how do I know which is the enemy paddle and which is the local paddle? Does that make sense? So it sounds like the Pong data is really got to have one more y coordinate. The y coordinate of the paddle for the server versus the paddle on the client. Because they can't have the same y positions or else they'll just track each other senselessly. And that wouldn't necessarily make any sense to anyone. So you know, if you're going to do it this way, then I say you'd better make sure that you modify your Pong data so that it contains an extra coordinate, the y position of the friendly paddle versus the enemy paddle. But for now, let's leave things as they are. Adding data to the Pong data will do nothing to our RMI framework, because we're just taking a data structure and passing it back and forth, and so at some point you may have to modify the toString method. You may have to modify, you know, the number of variables that the data structure contains, but in effect you will not have to modify the framework that gives the service a name, the framework that looks up that name, or the framework that passes the name from one side of the server to the other side in the client. So getting and setting Pong data has nothing whatever to do with what the Pong data contains. That's the beautiful thing about RMI. You have separated yourself from the contents of the Pong data itself. So at this point, I can change how this approach works, right? I can make it peer-to-peer by putting Pong data in, PD. And the interesting thing about altering the specification here is that it immediately will cause an error in the implementation, because the implementation will not have that specification implemented in it. So it's 412, and I still have to do an implementation, and I think I can do it, but I'm not sure I'll be able to follow through and go through and do a test. Not unless we're willing to stay a little bit longer. You know, so if it takes a little more time, I apologize, but I'll do it as fast as I can. But I don't want to blow anybody away. So let's go to this implementation, and now we see, aha, we've got a problem, right? We've created issues. And the issue is I have more methods I need to implement, and the set data method is now required. And that's what we expected. So now for set data, I have to be able to go to this .pong data and make it equal to the Pong data that was passed in. And what I could do is I could say, instead of sending data, I could say sout.control-J, quote, ... got data. And I could even print it if I like. Is that a good time? Sure, why not? So sout, Control-J, enter. Pong data comes in. Pong data. And now we've got a receiver and a transmitter built into the same remote Pong data implementation. It can receive and transmit. The server, well, what the server does is it registers the Pong data with the local registry. So the server is good. The server doesn't have to change. The remote hello implementation, you know, he says he's testing it by calling get message. Wait, remote hello? That's not the Pong data. Get rid of the remote hello stuff. We're beyond that now. So where are we? I wanted to run this server. Let's just run the server. Is there something I need to do in the client to change its behavior? Maybe. I haven't really done anything about the client yet. Let's just see if things will work the way they are supposed to. So here's the client. I got this console taking up way too much space, and I think there should be a nice way to resize it, but it's not cooperating with me. I don't know why. So I'll just minimize it. So now let's go to the remote Pong data client and give it a run.
Never actually did the set data
I
method.
know. I just wanted to get things going. Now let's look at the server. He says he's sending data, and here he got some data. So now let's shut it down. Go to the client. Sorry, was there a question? So here at test get message, he sends the data. Now I can do something like, instead of test get message, I'll just test message or test communication. Test, send, receive. And so he'll get the data, and now what we'll do is RH dot set data, and maybe we can make some new Pong data, or we can use the existing data. Good thinking. So we'll introduce a variable, extract a variable. Let's call it Pong data, because what else are we supposed to call it? And now what we'll do is we'll modify the Pong data. Pong data dot set score to be 100. That way we know we got through. And then we'll set the data. That'll send it over. When the Pong data is received, what happens at the remote Pong data implementation? It says receiving data, and it prints the data. So let's try that. We'll go to the remote Pong data server. We'll run it. And we'll go to the remote Pong data client. We'll get the data from the server, change the score to 100, send it back to the server, and have the server print something. So here's the client. Oh, shoot. Hit run. What could possibly go wrong? Shouldn't ask such questions. So now let's look at the server. Ah, look, score's 100. So now I have two-way communication between the client and the server. I can set the score, and I can get the score. I can actually set the Pong data. I can get the Pong data. Now, having done that, suppose you said to me, but Professor Lyon, your Pong data is all messed up because you forgot to do the enemy paddle position. I could say, yes, I know, but look at what you need to do in order to modify that. Go to the Pong data, call this y something. Now, y, perhaps you could have another one, private integer, shall we call it friendly paddle? Friendly y? How about y1 equals 20. And now what we'll do is we'll refactor by encapsulating the fields. So we'll go encapsulate field, we'll go to y1, we'll make a set y1 and a get y1 refactor so that we can see get y1 and set y1 are there. And now when the Pong data is printed, I think we better describe what y1 is. So what we'll do is we'll say, quote, y1 equals, end quote, plus y1 plus, and now I think maybe you're done. That's all you needed to do to add an extra variable. You don't have to go back to your framework for RMI or anything, because you're just passing a data structure across, and all you did was modify the data structure. When you recompile, it will pick up on the changes for that data structure. So what that means to me is I can just go straight in, run the remote Pong data server, run the remote Pong client, presumably it'll print out the default y1 value of 20, which it did, and the server prints out the 20 and also the score 100. So adding instance variables to the data structure that's being passed across using RMI is relatively easy because you're using RMI. Had you used sockets, it would have been a rather different story. So I thought, well, that's a reasonably good test of the robustness of the RMI system. And now it's 420, and that's all we have time for. What do you think of that? Groovy? Yeah? So will you guys work on this over the next week and bring your problems to class? When you're dealing with a final, I'm not going to feel at liberty to answer tons of questions after the last class prior to when the final is due. And next week, I think, is the last class, isn't it? That's it. End of the semester. So you all need to work on this. Now, how much of this should I be sending you? All of it. Okay. Shall we put it into a package or just? Yeah. Why not? Yeah, sure. So we've got this this thing here already called book examples. Mouse input. No, where did it go? Shoot. Here's the mouse example. It's under mouse input. Yeah. So that's the mouse example we worked. And we've got something for Pong, right? The Pong is under graphics, and it's in Pong, right? So why don't we do this? Why don't we put the mouse example and the remote nonsense all in the Pong package, and then take the Pong package and upload it to Blackboard? Is that how this works? Or attach it to the assignment as a zip file. So if that makes sense, what we'll do is we'll take the mouse example and we'll put it into graphics Pong. Okay? And that's now in graphics Pong. We'll take the remote Pong data, the remote Pong data client, the remote Pong data implementation, and the remote Pong data server, and we'll move it off to graphics Pong. So now when we look at graphics Pong, I hope I have everything in there that you need. We have the mouse example, the Pong data, the Pong program. We got everything we worked on today. So the way I'm going to do this. Was the regular Pong data in there? No. Where did the Pong data end up? Under simple example, RMI simple example. So this has to be moved also. Thank you for noticing that. So that has to be moved under graphics Pong. Okay? So now you got the Pong data, the remote Pong data, the remote Pong data client, remote Pong data implementation, remote Pong data server, RMI Pong, and Pong all in the Pong package. Got that? Yes? Okay. So now what I'll do, after having done all of that nonsense, is go into J4P, SRC, graphics, Pong, create a zip file, which should be in here somewheres, and there it is. And now, tell me again where you think that should be. You want to put that somewhere so you can find it, right? Here's the final assignment. How do you associate a file with that? Assignment submission? Attach file?
You have to edit the assignment.
How do you do that? Course content. Edit. Final assignment. Browse my computer. Lion. Lectures. Pong. Open. And then submit, right? So did that do it for you? Did you get it? Here it is, pong.zip. So that's everything you guys needed to jumpstart your final efforts. Pong.zip. And I'm going to upload this video so you can watch it again for your pleasure.
I have a question. So, like, where's the connection made to the game? Like, where is
Well, that's kind of a system-y kind of thing. To answer that question, the game has a couple of instance variables, and they include the enemy paddle and the local paddle, and what we did was we linked the two so that when you were in the game, they would track one another. But what we didn't do was we didn't link it to any of the RMI stuff. So you still need to make a leap toward taking all of the things that we've learned so far about mouse events, keyboard events, RMI services, and you have to link it to the game. So that's the part where I think you need to put on your thinking cap and really analyze the game and try and figure it out. And bring your questions with you next time.
that would be done, like, in the game as opposed to...
Well, that's a big question. That's an architectural question that you need to think about.
Yeah.
Kyle asked the question, how are we going to make the leap into figuring out how to link this into the game logic? And the answer is, you guys are going to have to put on your thinking caps and do some, heavy lifting in order to figure this out. And we'll bring those questions with us next week as we try and grapple with this task. And then next week, with those questions in hand, we'll try and address them. Okay? I'm not going to leave you guys, hanging, but I do want you to struggle with the problem a little bit on your own. It's the only way you're going to really learn from this assignment. Okay? Thank you.